do this thing to be that simple. What's that? What's your guess? No, not quite. You're on the right track, though. Okay. First of all, order matters. So what we say is matrix multiplication is not always commutative. Now, what do we mean by commutative? What's that? Commutative property, remember, is when you can switch the order in which you multiply. So, does 5 plus 1 equal 1 plus 5? Yeah. 5 plus 1 is 6, 1 plus 5 is 6. So, addition is commutative. You can switch the order in which you add. 5 times 1 is the same as 1 times 5. Multiplication is commutative. So, matrix multiplication is not always commutative. So, it is sometimes, but most of the time it's not. I'm going to write this down and I'll give you an example here. The number of rows in the first matrix must equal, hang on, sorry, got this backwards. The number of columns in the first matrix. Columns. The number of columns in the first matrix. Must equal the number of rows in the second matrix. Okay. So, you're going to have questions that will be like this. These are going to be the easier ones. Can you multiply the following product? So can you multiply the following product? Seems pretty split here.
Well, yes.
So this first one, now it has to be in this order. You don't flip these around. It has to be A first and then B. So how many columns does does matrix A have? 3. Remember, it's rows by columns. Okay? It's always written rows by columns. So a matrix A has how many columns? 3. Everyone okay with that? Matrix B has how many rows? 3. So you see, we call these the inside dimensions. Okay? So what your checkpoint is these have to be the same. So the inside numbers have to be the same. So yes, we can do this one. Now these outside numbers will actually tell us something as well. Those will be the dimensions of the answer. So the outside ones will be the dimensions of the answer. So That means I can multiply these, and that if I take A times B, my answer will have how many rows? 2. How many columns? 5. So it's just the order in which you say it here is going to be 2 rows by 5 columns. So A times B is going to be a 2 by 5 matrix. What if I take A as a 3 by 2, and I want to multiply it by B, which is a 3 by 3? Is that possible? Okay. Not possible. Your clue here is that these are different. So those are the problems that are like, yes, I can't do it, and you move on. Because if you do multiply them, it does take a process. You can. Well, this one you can. Is that okay, girls? Okay.
Wait, so you can't do it? Or
You cannot do this one. This one, you can't do it. Not possible.
why is it not possible?
I'll show you once we get an example. Because you don't have, the rows and columns have to match up with the same number in order to multiply. Yeah. What if I have a 5 by 6 and I multiply it by 6 by 1? Yes, and the answer would be what dimension?
5 by 1.
Okay. That part okay? Okay, now let's do the fun part. So we're going to start with a, let me get dimensions. Everyone got everything? Okay. So the actual multiplying, we're going to take, we're just going to do letters. We're going to kind of come up with a formula for this. I'm going to have A, B, C, D times E, F, G, H. So we're going to work through this one. I'll show you the formula that works out with this, then we'll put numbers to it. Now the first thing you always want to do is check your dimensions. And make sure you can multiply. So we're going to check our dimensions. Dimensions of the first one is 2 by 2. Second one, also a 2 by 2. So we're allowed to pass go and collect $200 on this one. Yeah. And our answer is going to be what size? 2 by 2. Okay. So that's probably going to be the second thing, is determine, determine size of solution matrix. Okay. Most important one here. Every row in the first matrix will be multiplied by every column in the second. Every row in the first matrix will be multiplied by every column in the second. Each part is added together. So every row in the first matrix will be multiplied by every column in the second. Each part is added together. And the answer goes in the spot where the row and column overlap. Big step. That's pretty much it. If you can figure out that paragraph, then you got this down. And we're going to go back up and I'll show you what I mean by that paragraph then. So every row in the first matrix will be multiplied by every column in the second. Each part is added together and the answer goes in the spot where the row and column overlap. This is one of those things, once you get it, it will be a lot better, a lot easier. Be able to do a lot of this in your head. So, up here, every row in the first matrix. So how many rows do I have? 2. So row 1 and row 2. I'm going to multiply them by the columns. So I have column 1 and column 2. Now, what that means is I have rows by columns. So just think of how we write our dimensions, rows by columns. The first row and the first column. Now notice I said first and first. So guess where this answer is going to go? First row, first column. Okay. I'm going to take A times E. I move over, I move down. You're going to hear me say that a lot. Move over, move down. So A times E, B will be multiplied with G. So it's not, you don't duplicate the letters or the spots. A times E, B times G, each part will be added together. So for this first row, first column, I'm going to say it's going to be A times E plus B times G. So I started first row, first column. The answer goes in the first row, first column. I start at the left, start at the top, multiply, move over, move down, add the parts together. See some fuzzy yeses and some, I'm not even sure about this yet. Okay, that's all right. So this is we say this is the first row, first column. So if it helps, you can write it up here. You know you're going to have a 2 by 2 matrix, so we're going to have 2 rows and 2 columns on our answer. So I'd have to take A times E, move over, move down, B times G, add them together. Okay, have that down. Let's go to this one. What is the spot here? What row is this right here?
Row 2.
No, this is still row 1, but so we say this is 1, 2. This is first row, second column. So let's go back to our first row, and let's go not to our first column, but to our second column. So now A will be multiplied with F.